hit the record button. Right, we can see you now as well, Kaimes. So
hello.
Oh,
marvellous.
So welcome back,
Okay.
everybody. Here we go with the afternoon session, and delighted to welcome Kaimes Beasley. I must confess, I don't know much about you, Kaimes, but at least I know where you come from, or where your name comes from now. So thank you for that. So you're lead marine coordinator, and you're going to talk to us about the Dogger Bank project, which clearly is a major event. So without further ado, I'll hand over to you.
Okay, thanks ever so much. I can't see myself, but hopefully I've done my hair properly for you folks. So, and can you still see my presentation?
All is good. All is good.
Excellent. Right. Okay. Good afternoon, everybody. Thanks ever so much for having me. It's an absolute pleasure to speak with you, or for you. So I'm, as it says there, I'm Kaimes Beasley. I'm one of the lead marine coordinators on the Dogger Bank offshore wind farm. What I'm going to talk to you about this afternoon for a bit, I'm going to set the scene with some introduction shortly. Then I'm going to talk about the Dogger Bank offshore wind farm project itself. I'll talk to you a little bit about the marine coordination function, and then looking at the vessel verification and assurance, because that was sort of the focus of this talk, and then look at some conclusions and try and answer any questions that you have. I recognise a couple of familiar names from our sphere. John, I haven't met you personally, but I think you're the John Williams that you work for the project occasionally. John Williams. So, but yeah, so I recognise a couple of the names. Anyway, let's move on. Right, so yeah, I'm Kaimes. I'm one of the lead marine coordinators on the Dogger Bank offshore wind farm. That's my details just there. A short bio about me. So I came into the renewables world in this sort of construction type activity just a little under 2 years ago or so. Prior to that, the main body of my career, I was Her Majesty's Coast Guard for 20 years, which was, I had lots and lots of fun, and did some very many interesting things working for Her Majesty at the time, His Majesty now, of course. And then after I departed the Coast Guard, and I spent a year or so working in the private sector as a company security officer for a ferry company, cross-channel ferry company, which also resulted in me becoming an ISM code auditor and lead auditor. So coming into this world it's been quite interesting, transferring some of the command and coordination skills that I developed during the Coast Guard, and then the sort of verification and assurance skills that I got through the cross-channel ferry company. But yeah, as I say, I've had it's been an interesting route into this world, but I'm absolutely loving what I'm doing at the moment. So the project, it's a big one. As Mike said, we'll start off where we are located. We're working out on the Dogger Bank in the southern North Sea. So we're solely within exclusive economic zone. Obviously, we're significantly beyond territorial waters, but we're solely within exclusive economic zone, which has some interesting consequences sometimes. Now, the Dogger Bank has a very interesting history, as I'm sure many of you know. Many years ago, it was dry land, connected, and so the UK was literally, if not metaphorically, connected to Europe, and it was known as the Doggerland. And then some glaciers melted somewhere up in Scandinavia, and the water level, the sea levels rose. Then the Doggerland itself became a bit of an island, and then eventually the sea levels rose to an extent that it's completely covered by water. So the Dogger Bank Offshore Development Zone, as it's described, that's located, as you can see, between 125 and 290 kilometres off the east coast of Yorkshire, and extends around just under 9,000 square kilometres. The water depths are interesting. Depending upon where you're working on the bank, it's anywhere between, say, 18 up to 60 metres or so. The main focus of our activity at the moment is in one particular area, which I'm going to come on to, and the water depths typically are varying between 25 to 40 metres. That makes for some interesting climatic conditions, though, with the relatively deep North Sea and the relatively deep South North Sea. and then the relative shallows on the Dogger Bank. So we are where we are because back in 2008, Crown Estate began its third round, the fabled third round of licensing for offshore wind development, which included the Dogger Bank zone. So back in 2008, the job that I was doing for the Coast Guard involved a little bit of work and consultation with the Navigation Safety Branch, the Maritime and Coast Guard Agency Navigation Safety Branch. And the round 3 licenses were issued, and there was all sort of interesting connotations of what it would bring, because the original series, the original round 1 and round 2 iterations of the offshore wind development were in relatively, well, they were in coastal waters, and they were in relatively shallow waters. It was all entirely within territorial seas. And then the round 3 came along. I'd say lots of interesting possibilities. And I remember back in those times, back in those days, back in that 2008 time, when these third round licenses were being tendered for or being offered, there was all manner of implications. You know, how was the development going to go ahead, and would they be occupied, permanently occupied structures? And then there's all manner of interesting consequences with the UN clause, the United Nations Convention on the Law of the Sea, as you know. So yeah, it was interesting times. So the typical lifestyle of an offshore energy project, it's basically in 4 phases. There's the development phase, which we're in at the present time, which we've been through, and then the construction and installation phase, which we're now into. And then you move into what's called the O&M phase, the operation and maintenance phase. And so that's where the actual wind farm operator comes in. And then in something like 35 years' time or so, there's the decommissioning phase, when we all have to reconvene and take it all down again. That probably won't be me, however. So in the development phase, I'll just spend a bit of time, just a brief look at these different phases. And there's I mean, when I joined this project, like I say, just less than 2 years ago, there or thereabouts, and it's mind-blowing. I'm going to say this quite a few times. There is nothing about this project that isn't mind-blowing, quite frankly. It's all just astonishing. The scale and the scope and the sheer size of what we're doing. But that development and consenting phase, which typically leads up to where substantive construction activity occurs, takes the form of lots of surveys. So, obviously for environmental requirements, lots of survey activity for fish and birds and so forth. The vessel traffic surveys. So are we going to be influencing, how much of an influence are we going to be having on vessel trading routes? And that's I remember when I was back with the MCA, that's a big deal. All the geotechnical and geophysical type survey activity to make sure what the seabed is going to be doing to when we're going to be building on it. Then we've got the installation of all the meteorological equipment. We've got a number of wave data gathering buoys out in the site recording for us. They report back to us. Because of where we're doing this and the distance from shore, and the consequence of how we get this data back to shore, there's lots of interesting again consequences and implications as to where we're building, and also as part of this phase, that installation of the boundary buoyage, and as I'm sure a lot of you know, these construction areas for many regulatory purposes come under the what would be the shore-based CDM regulations, the construction design and maintenance regulations. And so our boundary buoyage is our literal harass fence. When you see around a building site on shore, and they have to put the fencing around to keep everybody safe. So that's our sort of physical harass fencing around our construction site. Construction installation phase is what we're in at the present time, and that's when we're doing. That's what we're currently engaged with, and that's the substantive installation of the foundations and the erection of the wind turbines, and then all the other support structures, the offshore substation platforms, and all of the installations of the cables and everything else that's associated with the offshore development. And then finally, those last two operation and maintenance phase, excuse me, in the decommissioning phase, they will come. Because of the way the nature of this project, that operation and maintenance phase is in progress. The project, the operation and maintenance phase of the project will be being conducted by Equinor. So they're one of the joint partners of this enterprise. And in a minute, when I come on to it, I'll show you how we work with our Equinor colleagues. So we're out there in the southern North Sea, like I say. We're in, and there's this. It's a multi-phase project basically. So the principal phases are Dogger Bank A, Dogger Bank B, and Dogger Bank C. We refer to them as DBA, DBB, and DBC. DBC, actually, there's been a further development on DBC. The DBC area, the project planners have identified that they can, the DBC area has actually been split in two, and so a fourth phase, DBD, can be constructed alongside DBC. But the DBD project is currently at the consultation phase. So it's back to where this project was substantively like, I don't know, 10 years ago, I guess, with that consultation and the consenting rounds that need to go in order for DBD to gain consent. So DBA is what we're mostly engaged with at the moment. So that's the first phase of this project. And it's sort of the closest, if you like, to the actual shore, but still around 130 kilometers or so off the east coast. It's that graphic there, that's Flamborough Head, for those of you who are familiar with UK geography. So DBA is that's 130 or so kilometers northeast of Flamborough Head. Development area is around about 515 or so square kilometers. From west to east across DBA, to give you the idea of the scale, is around about 20 nautical miles. So it's kind of a large area. So 20 nautical miles across and about 15 nautical miles from top to bottom for DBA. And upon completion of the installation, the generating capacity of DBA will be around about 1.2 gigawatts. Dogger Bank D, Dogger Bank B is just to the north of Dogger Bank A. Again, it's around about 130 kilometers from shore. That's Flamborough Head again. It's one of the largest areas in the project, so almost 600 square kilometers. And again, that's going to have the order of it's around about 1.2 gigawatts generating capacity. The activity DBB, we have started up in DBB. We've got some activity going on up there, but the main focus of the activity is still currently in DBA. So the Dogger Bank A and B combined generating capacity of 2.4 gigawatts. We've got an export cable laid. Each export cable, in actual fact, there's 2 export cables per site. And they extend around about the export cables by the time they've departed from the UK coastline and have routed out to the locations in the centre of the developments. The export cables are around 170 kilometres long, approximately. Those come in, making landfall just south of Bridlington, where it says there, north of Ulroom on the east coast, and then they travel underground to a onshore converter station and then pass through into the national grid. DBC, at the present plan, it's around about 1.2 gigawatts total capacity, and development area is about 560 square kilometers thereabouts. Furthest point from shore is just under 200 kilometers. And that export cable is following a different route to the DBA and B export cables, and it's coming ashore just south of Redcar, further on the east coast. So the total generating capacity is around about 3.6 gigawatts. Like I said, we are embedded into the Equinor O&M base. So we are working out of the port of Tyne. in this very nice facility, and we're embedded with our Equinor colleagues. The actual builder of the principal contractor for the project is SSE, which is the company I'm contracted to. But obviously we're collaborating very closely with the people who are going to be running the wind farm developments in total, Equinor, out of this building here. The building itself, it's really quite a nice place to work. It's won all sorts of design awards. You can't see it, but all of the roof surfaces are covered in solar panels, and so the building has won many awards for sustainability and so forth. And like I said, it's quite a nice place to work. The O&M base houses the control room, who we are working with principally, and they're going to be monitoring the output. It's basically 5%, 3.6 gigawatts total out of DBA, B and C, and that's around about 5% of the UK's electricity generating capacity that's going to be produced offshore. And for comparison, well, I'm sure some of you know this, that's around about the same size as a nuclear power station, that generating capacity in total. So that's all being managed from the control room just here. Consequently, that sort of facility, or these sorts of facilities, they end up as they're described as what's called critical national infrastructure. So what are we building? We're building these, the GE Haliade-X wind turbines, and I'm just going to spend a little bit of time looking at these because this is one of the most astonishing, or these are one of the most astonishing parts of this project. The Haliade-X, they are well, the figures are mind-blowing, quite frankly. So there's three types of the Haliade-X. In Dogger Bank A and Dogger Bank B, there will be 95 of the Haliade-X type turbines in each of those locations. So 95 in Dogger Bank A, 95 in Dogger Bank B. Dogger Bank C is the next generation of the Haliade-X, so there's going to be 86. It's around about 86 of the Haliade-X next generation in Dogger Bank C. But the generating capacity of these wind turbines is up to 14 megawatts, which compared to the round 1 and 2 offshore wind turbine developments, they're typically around about 3.5, or around about that size of generating capacity, or slightly smaller as well for some of the round 1 developments. They are, quite frankly, huge. So they've got a 220 meter rotor diameter. The blade length is around about 107 meters. The total height from the sea surface up to the very tip of the blade height as it's coming across the top of the arc is around 260 meters. As I say, this is all mind-blowing. I mean, it's frankly staggering. The blades are doing 10 revolutions per minute when they're in operation. So if you do the maths, that blade tip is doing 250 miles per hour, or 400 kilometers per hour. A single sweep of the blades would generate sufficient electricity on average to power 2 houses for a day. It's just, as I say, it's remarkable. That 38,000 square meters swept area for the blades, that converts to approximately 9 acres. It's like 4.5 or 5 football fields, something like that, but 9 acres approximately. So when I'm with friends or family or similar, and if you stand next to a 9-acre field, and that's the swept area of these blades, it's just truly mind-blowing. So I've just got a short time lapse here for you of this was the building. There's a prototype. The prototype Haliade-X was built in Rotterdam, and when I used to sail into Rotterdam, and I saw this was before I joined this project, and I saw this wind turbine there. And the first time I saw it, I thought, gosh, that's a very, very large wind turbine. And then I didn't realize when I fast forward into the future that I'd be working on a project where we were building these things. So I'll just press play on this and hopefully this will work. So hopefully that worked for you. When it sort of puts into perspective the scale of building of these things. The nacelle weights, for example, the nacelles weigh around about 670 tons. So yeah, it's all mind blowing. Okay, the other elements of that we're constructing, that's just a shot from the yard in Rotterdam, where some of these items are marshalled out of. So the foundations, there's the monopile foundation that goes into the seabed, and then the transition pieces are in the distance on that particular picture that you can see. The monopiles are some of the largest monopiles being used currently on offshore wind development. They're 8 meters in diameter, typically, depending upon the water depth. They're maybe between 50, 60 meters in length or more sometimes, depending upon the required penetration. The weight of the monopiles is anywhere between 11 and 1,300 tons, thereabouts. They average around about 1,200 metric tons for the monopiles. The transition pieces that slot on top of the monopiles, they're typically, for these ones, they're around about 550, 60 tons. So it's just astonishing. I mean, of the 95 foundations that we've got in the seabed in DBA, just in the monopiles alone, it's over 122,000 metric tons of steel in the monopiles themselves. And it's just under 60,000 metric tons of steel in the transition pieces. For the export cables laid for DBA and B, it's around about 340 kilometers of export cables, and these are dinner plate sized diameter cables. There's 2 cables for each development for A and B. So those have been laid and have been trenched and buried. At the moment, within the field, we've got around about 122 kilometers of inter-array cables laid. So that's what, 70 something miles thereabouts of inter-array cables. So these are strung between the wind turbine locations and are all brought together at the offshore substation platform. And just to give it a sort of a local flavour, or a local bit of comparison. So the Tyne Bridge, which is just over there, literally, is about 4,000 tons of steel in the Tyne Bridge. So in the monopiles, we've got 38 Tyne Bridges worth of steel. and the Tyne Bridge, the walk across the Tyne Bridge is about 160 something meters. So you'd have to walk 755 times backwards and forwards across the Tyne Bridge at the moment to replicate the extent of the interarray cables that we've currently got laid. It's just around about half or so of the interarray cables we've got laid, so there's still more to come. It's, yeah. A little bit on the marine coordination function. It would be remiss to not just mention what I do. We are basically we're trying to manage and coordinate all worksite activities, and that includes the verification of all vessel and crew certification as part of the onboarding process, which I'm going to come on to. But we're here to help the vessels basically for what they're doing. So we're providing information on each other's movements and advice to the vessels. The distribution of the forecast, both the area forecasts for the weather and also the lightning reports, because obviously that plays a significant part in the construction activity. We are, however, looking at enforcing project requirements and the limitations for safety. That's one of the principal things that we're doing. We're tracking all infill personnel, and lastly, we're coordinating emergency response. Of the marine coordinating cadre, it's 24/7 operation. There are 2 of us lead marine coordinators, me and my back-to-back. We do 2 weeks on, 2 weeks off. Excuse me. And then there are 4 duty marine coordinators. And of the 6 of us, 5 are ex-Coast Guard, because those command, control, and coordination skill sets are very transferable for that maritime coordination activity. So vessel selection, vessel onboarding, and that's the sort of the meat of what I just want to talk about. And it's to do with when we bring a vessel onto the project, and what do we do and how do we go about it. And so it's all about effective vessel selection and operation. And so there's quite a lot of factors involved. I'm going to briefly have a tiptoe through some of these. And it's all about making sure that the vessel that's coming onto the project is appropriate for the activity that it's going to be conducting, basically. And because of where we're working, the regulatory regime is interesting. So the vessel selection, and basically, is it fit for purpose? Can it do what it is going to be required to do? So there's an assessment of the activity it's going to be carrying out, how long it's going to be doing it for, where it's going to be doing it, and so forth. The competence and experience of the people of working the vessel, but also the project crews, the project personnel who will be embarked upon the vessel. The safety management systems in place. Now, there's a lot of this type of activity is regulated by either national or international jurisdiction, or rather international requirements that are converted into domestic or flag jurisdictional requirements, but these will have to be complied with. Then any specific equipment or facilities that the vessel requires in order to the activity to be carried out. There's broadly, activities can be divided into these sort of 3 areas. So pre-operation, that's selection of the vessel, everything, mobilization of the equipment and the personnel to the vessel, and then during the operations, i.e. it's carrying out its activity, and then post-operation, that demobilization phase, which is a consideration. Health and safety management is obviously significantly important. So we're checking and verifying the operation of the safety management system, the SMS system, which for the vessels that we're using typically involves, because they're big ships over 500 gross tons, so that will obviously involve any ISM code requirements and those international requirements. Jurisdictionally, you can say we are UK exclusive economic zone, but so we do a fair amount of work with my ex-colleagues in the Maritime and Coast Guard Agency and the MCA for some types of activities, and we are using jack-up vessels, and so making sure that they comply with the particular elements of the what reply to jack-up vessels. In terms of verification and assurance of the roles and responsibilities of the vessels. So again, this is the safety management system and assessment that it's rigorous and appropriate. All of the companies that I have interacted with, and then the companies in my, or the company rather, in my previous life, this stop work authority is significant, and I've not yet come across anyone who doesn't take it seriously, to be honest with you. This stop work authority and this powering of stop work authority, and it's a big part of this project. The project phrase is, if it's not safe, we don't do it. That's an SSE thing, but if it's not safe, we don't do it. And that one is not just lip service. The interactions between when bringing on a vessel, that there's many complex. There's many interactions basically, and so these are between the vessel operator themselves and the contractor, and then also the project, or in our case, the developer, in our case, the project that I'm working for. And so those interactions need to be managed and need to be spelt out. And so there's a lot of work done with that when we bring on a new vessel. Training and competence, we look at the marine crew training and competence and their certification, and the project personnel, their entitlement and their certification to be working offshore. So that's a big part of what we do in the Marine Coordination Centre, that verification process to make sure that everyone is appropriately certificated. Medical training, that's a big deal for where we are working, because we're so far offshore, and the principle is that we as developers need to be largely self-sufficient. There are obviously times and requirements to call upon shore-based emergency response capabilities, but the medical capability that we have to have as part of the project is quite rigorous. Medical certification, this is a given. Everyone working offshore has to be certificated properly. The ability for a vessel to operate effectively in an environment of simultaneous operations. So those are managed, the hazards are identified and risk assessed, and there's careful management of those. But this is a consideration when we're bringing on a vessel. Marine coordination. I'm bound to say that effective marine coordination to manage the vessel traffic and to address emergencies is essential, of course, as part of that ability for that vessel to operate with us. The sea state and weather factors, and the ability basically for a vessel to actually operate effectively within the areas that we're working. And then all of the other health and safety aspects relating to this is principally, it's not just contained to the actual activity for the vessels, for the day-to-day operators of the vessels, but also for the project personnel who will be transferring to assets and going to be transferring to where they're going to be working. So there's all manner of hazards that need to be identified and assessed and then mitigated. Just one thing, by the way, on that weather bit, which I just forgot to mention. So the passing of Storm Babette, 3 weeks ago or so, from our wave data gathering buoys, we set some new records for the data that we were getting, and we were seeing 14 meters maximum wave height on our northern data buoys at the north part of the Dogger Bank A area. So 14 meters H max, and it was around about 9 meters H sig, there or thereabouts. But that was a new record for us on the H max. Needless to say, there wasn't any work going on when that was going active, when that weather was coming through. Broadly, and finally, the suitability assessment when selecting vessels falls down to these 6 key areas. So the activity to be carried out, the nature of the site where it's going to be carried out, what the vessel facilities are, not just the capability that provides in a working environment, but also for the crew. Comfort is a big comfort, and decent working conditions, maritime labour organisation, so forth. Those are big factors. The vessel and incident management record or processes that the vessel is operating under. And finally, that mobilisation and demobilisation process in order to make sure that a vessel is brought on efficiently and safely. and timely. And thank you very much for listening.
James, wow. I'm sure there'll be some questions, but from the office here in Porchester, you've wowed Hilary and I. And they say that every day is a school day, don't they? And all I know is I've just learned a great deal. And I do have a question for you.
Yes, sir.
Which you probably can't answer, but I'm going to ask it. You know, lay people, and I probably include myself in that, know almost nothing about this work, about what's going on. We occasionally see something on the BBC News that says, you know, Dogger Bank's progressing and it's all very exciting, so we hear nothing more. Why are we not bigging this up? I'm putting my UK hat on. Why are we not bigging up this piece of work? And you know, why are the media not picking this up on a more regular basis?
That's a good. I don't know, to be honest with you, because part of it, and I'll put it this way, part of it is quite routine, in as much as, you know, the build goes ahead, and you know, and in my previous life when I was wearing my Coast Guard hat, the spectaculars, you know, that I was involved in, because I had quite a few. I managed and dealt with quite a few interesting situations in my Coast Guard career, especially when I got to a more senior position. It's the spectacular situations when things go terribly wrong, where that are likely to attract the attention. And personally, I was involved in some interesting stuff, and I've got some good stories. But yeah, it's the relatively routine nature of what we're doing in terms of the construction, because obviously, because if it's not safe, we don't do it. We're just going to build this thing as, you know, safely and not hurt anybody or harm the environment whilst we're doing it. But the point that I mean, as I say, nothing about this project hasn't blown my mind so far. In the substantive construction phase we're in, we've onboarded, it's over 70 vessels that we've had onboarded onto the project. And this is everything from the very large construction vessels that we've got doing the major installations, down to the small guard vessels that have been guarding exposed cables whilst they're waiting to be buried. And that, over those 70 vessels, I mean, we've got over 5,000 people registered in one of our systems that we've gone through the verification and assurance process to check their certification and so forth. And you think that's 5,000 real people with, you know, with real lives and real jobs. So, you know, there's so many elements to this project that, you know, you're right. I think, you know, we could and should be trumpeting. These large scale infrastructure projects provide an awful lot of, you know, good quality jobs. And going forward, this O&M, this base where I'm working, we work from at the moment, this O&M base, you know, these are long-term jobs for an area that, you know, that really warrants it. So I don't know.
But yeah, it's interesting. I mean, I went up to Blythe maybe a couple of years ago now. The last time, if those who don't know UK geography, Blythe is up on the northeast coast in the sort of Tyne area. And it was probably 30 years since I'd been to Blythe. I just remember Blythe as being a very rundown. There was no employment there, high unemployment rate. It was dreadful. 2 years ago, the harbour was full of all sorts of vessels there servicing the wind farm industry. And it's a very significant employer, isn't it? It really is.
Yeah. And yes, indeed. And you know, to my way of thinking, these are sustainable jobs. RWE, I shouldn't mention this because they're not a competitor, of course, but RWE is building the Sophia field, and they're also on the Dogger Bank as well, and their marine coordination centre is just around the coast in Blythe, as you say. And you're right. You know, when where this Port of Tyne building was based, this used to be shipyards. You know, from end to end, and there's some marvelous pictures. I can't remember the name of the tanker. There's a picture taken. It's back during the 70s, and it was a very large tanker being constructed, and basically the bow is looming over the houses. So all of those industries went, but bringing this sort of industry back into these sorts of areas, I think is marvelous.
Yeah, it's really fascinating. There's a question there actually for you. Are you able to pick it up on chat? I can read it otherwise.
Let's have a look. I don't do Zoom terribly often. Are utilized in, yes, are EC-MEDs utilized in the vessel selection for the project? Yes. Yes is the short answer. Yeah. So part of that there's basically three elements to that onboarding process when we bring a vessel on to the project from the verification and assurance process. And part of it is a suitability survey, depending upon the nature of the work the vessel is going to do. So there's a suitability survey, there's a health and safety inspection, that's a project requirement, and then there's an environmental compliance inspection that's conducted on the project. So those are three elements, which form part of the site entry process. So once the vessel has completed the site entry process, then that's when it's allowed to come into the construction area. Part of that site entry process is also a review of the CMID, if it's been done that way, or the e-CMID. And any sort of reports or closeouts or any sort of subsequent follow-up actions that's required from those inspections. But yes, sorry, the short answer to your question is yes.
Fantastic, thank you. Any other questions for Kaimes? Any other observations or thoughts? One more question from me then. Given the distance offshore, are you working there with motherships?
Okay, so yeah, conventionally the sort of the round 1 and 2 offshore wind farms, they typically would have a fleet of what are known as CTVs. So now they've gotten larger over the years as the industry has developed, and safer ways of working as necessarily meant to change to the design of the CTVs, the crew transfer vessels. We are exclusively using what are known as SOVs, so service operations vessels. We've got a number of new builds, or there are a number of new builds that have been constructed specifically for the O&M phase of the project. And these are typically of the order 80 meters, 85 meters long. They're 20, 30 meters beam, something like that. And they are almost exclusive, well, they are exclusively using what's called a motion compensated gangway. Also known as a walk-to-work system. So you'll typically see on the service operation vessel, there's a large center pedestal that rises from the deck, and then at the top of that will be the motion compensated gangway, which is how the transferring technicians transfer between the vessel and whichever location that they're working on. Going back in previous years, you know, when it's just a development of the way this industry has gone, and making things safer by design. You know, part of one of the awards that this project has won previously is this safer by design concept, i.e. trying to design things as safely as possible to design out the hazards. And part of that is simply a function of the technology, or the development of the technology in the industry, for example, by these motion compensated gangways.
Interesting. Yeah. Any other comments, questions? I might ask you to stop your